Okay, so today's lesson is all about linear equations, and you're going to see that function tables, input-output tables, go right along with graphing. So the chapter reference is chapter 12, lesson 4, and the materials you're going to need for today's lesson: spiral notebook, graphing note sheet that I gave you in class, the one with the 6 different quadrant planes, a ruler, and also you're going to need a red, orange, and yellow crayon. All right, go ahead and pause the video and go get those materials, and then come on back and we'll continue on. All right, so the vocabulary you need to make sure that we record down are domain, range, and function. Domain is just a fancy word that means the x value in an ordered pair, or also the x value in a function table. The input value is really what the domain is. The range is the y value. Again, it's the output table or the y value in an ordered pair. And then you have function. That's an equation or a rule or a pattern that goes along with the function tables. Make sure you have all 3 of those vocabulary words written down. If you need to pause the video, go ahead and do so you can write them all down. You can write in the definition, or you can write a picture to go along with it. All right, to start off with a function table. You've done function tables before, and they've been called various things over the years. In elementary school, they call them input-output tables. You've also seen them where you have the x value on the top and the y value on the top and the equation in the middle. And then also domain, range, and function. I just want you to show how do those vocabulary words really relate to a function table. The x value is usually written first, also called the input value, also called the domain. The equation can be called a rule, could be called a pattern, can also be called a function. The y value can be called the output, and it can also be called the range. So different vocabulary words for the same exact thing. Just get used to hearing different words. Just like you could look up a word in the dictionary and have multiple definitions, this is the same thing. Here you have a function table. You can see the input values, the output values, and the rules. So we have, here is our equation, 2x equals y, and our input value is 0. So what you would do is, everywhere you see an x, you would take that x out and substitute in a 0. So 2 times 0 will give you what? It gives you 0. So that's your output value. For 1 is going to be substituted in for the x. 2 times 1 equals 2. Again, negative 2, substitute in for the x. 2 times negative 2, and that's going to give you negative 4. You could pick any x value. Let's say we picked 5. Go ahead and substitute that in to the equation and see what you get for an output. Did you get 10? Awesome. If you don't have that table copied down, go ahead and pause the video. Otherwise, we're going to move on. Here's yet another function table. Again, we have our rule or a pattern in the middle. It's a different pattern because it's a different function table. So our input values are 0, 1, and negative 2. I want you to practice. Go ahead and put your input values into the equation and see what your output values come out to be. Here are the domains. Figure out the ranges. Go ahead and pause the video and do that on your own, and then we'll check your work when you're done. Okay, let's see. 3 times 0 equals 0. 3 times 1 equals 3. And 3 times negative 2 equals negative 6. All right. Let's slide this over here. Here's a function table that's already been done for you. You should be able to look at a function table and be able to figure out the pattern. If you did not see this at all and you were just looking at the input and the output values, could you figure out the pattern? If you go from 0 to 3, negative 1 to 2, and 2 to 5, what do you notice is the pattern? Do you see how those input-output values are larger? So you know you should be adding or you should be multiplying. In this case, we're adding 3 each and every time. Always make sure you check for every single pair of values. That way there you can make sure that it truly is the pattern. Sometimes they're going to try to trick you and make it work for the first two, and then the rest doesn't follow suit. And they're going to put that on EOG guaranteed. So make sure that you check for every single pair of values. Here's a function table. Go ahead and copy that function table and see if you can figure out the pattern. All right, hopefully you saw that this is getting smaller, smaller, and smaller. So what exactly is happening here? If we subtract 4, -1 minus 4, 2 minus 4, do our keep change change, 0 plus -4, -1 plus -4, and 2 plus -4. That works each and every time. So let's write our equation up at top. What is the function? What are you going to do to the x? You're going to take the x and minus 4, and that will give you the y value. You should be able to look at a function table and figure out the pattern. Some are more complex than others. For the most part, we're going to stick to 1- and 2-step functions. Now, when you look at a function table, what you're also going to find is that you can take a function table and take the pattern and go ahead and make a graph out of it. So take a look at this function table here. It's already been completed for you. You've got 0, 1, and 2 as our input values. Here is our equation, 3x equals y. 3x equals y. So for every x, you're going to take out and put in whatever the input value is. 3 times 0, 3 times 1, and 3 times -2, and you have your outputs here. This table can actually be changed into an ordered pair. Do you see how x and y makes an ordered pair? Well, here's your x and here's your y. So that would be 0, 0, 1, 3, and -2, -6. Do you see how you can take the table and just make an ordered pair for each one of those values? Now you can go ahead and graph them. Go ahead and take your coordinate plane sheet that you were given, and we should be on example number 2. So this would be number 2 on your coordinate plane sheet. Go ahead and graph each one of those ordered pairs. Do you notice that you can connect the dots? Use the ruler and go ahead and draw a line. This is called a linear equation. This equation makes a line. Do you see the vocabulary there? Linear, line. This makes a line on a coordinate plane. It's an equation that when you graph it, it makes a straight line. All right, take a look at this next one. Go ahead and copy the function table. And at any time you need to pause the video, you're welcome to do that. All right, here is your function table. I'm telling you that your input values are 0, 1, and 2. You know what, let's make that a -1. It's always good to have a 0 as one of your inputs, a positive number, and a negative number, just to make sure you can cover all the quadrants in the coordinate plane. So use these 3 input values and go ahead and find your output values. That's step 1. Find all your output values. Pause whenever you need to. Okay, hopefully you've done that. You've got -3 times 0, that equals 0. -3 times -1, that equals 3. And 2 times -3, which equals -6. Step 2 is to write those as an ordered pair. 0, 0, -1, 3, and 2, -6. And step 3 is you're going to grab your coordinate plane sheet and you're going to go ahead and graph those ordered pairs. You should be on your 3rd coordinate plane here. Grab a new coordinate plane and go ahead and graph those points. Now I am using a self-made graph here, so mine might not be as exact as yours, which already has the grid lines. But once you have those 3 points, go ahead and connect the dots. Whoops. As straight as you can. You have a ruler, so that will help. Do you see how you have a straight line that goes through the origin? This is a linear equation. Again, there are 3 steps. The first is to complete a function table. The second is to take the function table and make ordered pairs. The third is to graph those ordered pairs and connect the dots. 3 steps to create from an equation to a line. Did you notice the difference between these two? This one, blue graph, is pointing in this direction. This one is pointing to the left. Do you see the difference? Can you look at the 2 equations? What's different about them? The difference between the equations is what's creating the different line here. Hopefully you notice that this is a positive 3 and this is a negative 3. Anytime you are multiplying by a positive 3, line is going to point to the right, and a negative 3 is going to be pointing to the left. We'll do some more practice with that as the time goes on. But you do need to know that the way the line goes is dependent upon whether it's positive or negative. Go ahead and try these 2 examples. Pause the video and then come on back and we'll do it together. You can check your work. Step 1 is to complete the function table. Negative 2 times 0, negative 2 times negative 1, and negative 2 times 2. Step 2 is to make the ordered pairs. And step 3 is to graph. You should be on your 4th coordinate plane. If your dots do not make a straight line, you've done something wrong, and that's a way for you to check your work. You can go back and check your multiplication and be sure that you have that filled in correctly. Now, notice this is a negative 2, so it is pointing to the left. Can you anticipate what this graph will look like? It's a positive 2x. Let's take a look. You've got 2, 0,